Scenario. A block slides down a distance L along the ramp from rest. The ramp makes an angle theta with the floor. Question. Assume the ramp has friction now. What is the kinetic energy of the block at the bottom of the ramp? If you did the previous problem, you'll see it's the same thing with a little modification. If not, you're going to see the problem done from scratch. The answer. The approach is the same, which is using conservation of energy, because the total energy from the top is going to be the same as the bottom. But there is some reduction due to friction. So it should be E top equals to E energy at the bottom. That's how it should normally look like. The energy at the top was only defined by the gravitational potential, which was mgh. That h was L sine theta. That was equal to the kinetic energy at the bottom. However, we have an issue here. I showed you here to use the trig if you want to learn how to get the height. But there is a subtraction due to work being done by the force of friction. That force of friction, work is defined by force times distance. The force of friction is the force, and the distance would be d cosine theta. That is the work done by the force of friction. The force of friction can be defined by mu, and n stands for the normal force, and times d cosine theta, which is the distance it went down. We have a value here for the distance. The distance that it travels down is L. So you can have that substitution there. So lastly, here we see that the equation can now all be subbed in to be mgl sine theta, which represents the gravitational potential, the minus mu mgl cosine theta, which represents the work done by friction. That minus is because the energy is coming out of the system, and that's going to be equal to your k in the bottom. You might see it in a different version because they might factor out the mgl, and that's because that are your like terms, leaving in the parentheses sine theta minus mu cosine theta. Please understand that this really actually looks like just mgh. But the h value here is defined by the L with a parentheses of the difference in the sine minus mu cosine theta. All right, so there you go. This is the energy of the block going down the ramp with friction removed from it.